Hello, serverless people. Welcome to the second episode of the Serverless Architecture Challenge. This is like a challenge that was created by Sam Williams from the Serverless Masterclass. If you want to subscribe to the newsletter, I'm going to leave the details on the description of this video. I think it's pretty cool because you get a challenge every couple of weeks and you can, exercise on your architecture skills. So let's get started and see what this new challenge is about. This new one is about like creating a virtual event platform. So business details, founder has identified a need for a virtual event management platform. The target users include companies organizing interactive community events and hackathon. The goal is to provide a solution for planning, hosting, managing virtual events, including features such as event planning, virtual venue creation, ticketing, and analytics for participant engagement. And then you have like a set of requirements that we're going to go through. So it's basically event planning and scheduling, ticketing system, virtual venue, which is basically like streaming a video event. And then the hackathon teams where you basically have a chat room where teams can send messages in like basically like a Slack group, I guess. And then team can submit their submission for the hackathon, and the host can, review submission and give a feedback. Then for the host and for the owners of the platform, you can get analytics for the engagement and also data, exported data about participants. You also have a list of non-functional requirements, which are like web application needs to be sub 2 seconds, so like the API response to be sub 2 seconds. Then video needs to be streamed with 5 seconds latency maximum, HTTPS, GDPR, support events with up to 500 people, accommodate a total concurrency of 5,000 event participants across all clients, and then you also have a budget and timeline. So with this in mind, let's go through the exercise and how I solve it. So the idea here is to show you my architecture. I'm going to go through all the questions that Sam has sent along the challenge and discuss them basically. All right, here is the file where I submit my architecture and my answers to the questions. It's on GitHub, on my repo, and also the pull request is on the Serverless Challenge repo. I'm going to leave again the URL on the video description so you can go there, have a look, and if you want also like add some comments so we can discuss. And I think it's cool if we give feedback to each other. Let's get started and go through the requirements. So event planning and ticketing. So allow organizer to plan and schedule virtual events, provide a user-friendly interface for setting up event details. Organizer can invite people to be co-hosts, okay? And organizer can create a set of judging criteria. This means the participants know what they're going to be doing, okay? So for this list of features, I thought that, a reactive mobile application can handle all of them. So the organizer can, log into the application and create and schedule events. I imagine like, a page with a form where you can create and another page where you can see the list of scheduled events. For this app to be can be hosted on an S3 bucket with a CloudFront distribution. So we have, HTTPS and also redundancy in all the edge location of AWS. For the authentication, I'm using Cognito, which is the authorization service from AWS. And if hosts wants to invite co-hosts, it can be handled as a role in the Cognito system. I think the idea is to use user pools with a different set of roles, which are defined in identity pools. So kind of, using Cognito user and identity pools for handling different roles. And for the ticketing and registration system, the requirements are like implementing a ticketing system for event registration, and provide option for different ticket types and pricing. So for this, again, I imagine the same app to handle the ticketing to handle the ticketing system, where the hackathon participants, the guests, basically, they can buy a ticket and entry a new registration. So every time there's a new registration, this calls a Lambda function that creates an entry on a DynamoDB table where all the participant details are stored, along with the ticket type and the price they paid. In the challenge, there is no explicit specification on how we're gonna handle the payment system. But maybe we're going to use Stripe, so we may need to integrate a callback to check if the payment was successful or not. So the idea, again, the architecture is the API gateway with CRUD events for create, reading, update, delete events, then a Lambda function to invite a co-host. So here maybe it's an email module is missing, so maybe to invite a co-host to send an email with a registration link. And then here a Lambda function to create the ticket and save everything on a DynamoDB table. And here is where the React application is going to be host, so on CloudFront application with Amazon S3 bucket. I hope this first set of features are clear. I know it's a bit high level, but I think it's also kind of the goal of the exercise. So let's move to the next set of features, the virtual events. So as we said, we have an events platform, but obviously this event is going to be online. So host can, live stream like a presentation of the hackathon, and participants can, collaborate with each other based on the theme and using a chat room application. So imagine like a Slack or Discord channels where everyone can speak to each other with a text message. So the virtual venues are web application where hosts can live stream a welcome video to all participants. Participants can ask questions in a live chat. Okay, so there's also live chat during the live streaming. There are different ways to implement this. Okay, this is my answer actually. So there are different ways to implement this with the live stream, with third-party providers, Vonage Video or Agora, Daily. There are a lot of third-party providers. But I'll try to stick with AWS. So video, needs to be streamed from a webcam of the host, and the latency has to be sub 5 seconds. Also, the participants can be up to 500, so we need to keep this in mind. And for this reason, I actually choose to use a Chime SDK to push the video from the client, from the laptop or from the webcam of the phone to an RTMP endpoint. You can follow this guide to using Chime SDK to do live streaming. And then for the RTMP, I can create an HLS stream and having an HLS player on the web page where people can consume the video. And this is going to give enough room to have 500 users watching the video. And also for the live chat, the users that are going to join the live streaming are going to connect to a WebSocket, because it has to be live chat, so we need real-time features. And I'm going to use again API gateway with the WebSocket API and Lambda functions. So when you're using API gateway for WebSocket, you have a few endpoints that are kind of I would say native for WebSockets. So you have a connect endpoint where the participant connect to the WebSocket. Then a send message endpoint where participants can send a message using the WebSocket, and then all the other users connected to the same room, let's call it room, but to the same WebSocket are going to receive the message, and a disconnect endpoint. So I had a look on the documentation of AWS. There is a way to implement a sort of rooms, so using You can use a kind of a ID, maybe using the event ID. You set up a room ID for the live chat, so only the messages that are related to the single event are going to be sent to the right participants. So you don't want to, mix messages between different events. So you can use a sort of, DynamoDB table to link room ID and connection ID on the live chat, and then having this chat room on when there is like the live event. So this can be a separated application, again using maybe React. So you have S3 CloudFront where you can consume the live video and also connect to the API Gateway WebSocket. And from here, with the DynamoDB table, we're going to link room ID or event ID with the connection ID that are related to the specific event ID, and then users can send and listen messages. Obviously, I want to also like store those messages so people that are like disconnecting and rejoining can see the history, and also want to store connection and disconnection to be able to have analytics on the event. So the idea is to store everything on a separated like DynamoDB table. Now let's move to let's say the live video has been, the live hackathon, the hackathon challenge has been created. So now it's time for the teams to collaborate, and here you can create breakout rooms. So the idea on the breakout rooms is very similar in terms of like, it's going to be a chat room. So I'm going to use the same logic of having API Gateway and WebSocket with, connects and messages, connect endpoint, and basically participants can send text messages. I'm saying text messages because if we want to handle images or file in general, probably it's better to have a dedicated like S3 bucket where you can upload files and just share the link using the WebSocket message, because there is like a limit on the payload size. I think it's like 32 kilobyte. So like the way I will implement, file sharing on a chat is like uploading the file to S3 and then share the link with the chat room. So yeah, the logic is the same as we said before. So each breakout room is gonna have its own, let's say, room ID where users can join based on the team, and also the same thing for hosts. If a host need to join, you can join the specific room. So next one is a team submission. So here is saying the requirements at the end of the hackathon. Teams can submit their project. This includes description and details, but also file upload for any files required. Host and organizer can view all submissions. Okay. And obviously, sorry, the host can, give feedback on the submissions. So for this idea, for these requirements, I thought of having like an S3 bucket with a path where you set a hackathon ID or event ID, a team ID, and a submission where teams can, upload files, and host can see these files can download the files basically using a SAN URL from S3, for example. And then once hosts are ready to submit their grade, they're gonna call a Lambda function to add basically their vote, and then every time there is a new feedback on the project, the Lambda function is going to send a message into a queue, and this queue is going to be there's a Lambda function is going to read this queue and send an email to the participants to notify them that a feedback has been added to their project. I thought about this because I think it's easier probably to separate the notification part with the grade, the feedback submission from the hosts. Still need to think about it, but hopefully it's a good design. Then there's the analytics requirements for the participant engagement. So here about how we want to measure the engagement of the participants, so we can about checking how long they stay connected to the live event, so where we present the hackathon, and also like use the number of messages exchanging in the room, and also the connection time in the chat room. I think it can be like an indicator of engagement. And the idea is that we have this data on DynamoDB table. So hopefully by running queries, we can display this data. And I saw there is a way to get the DynamoDB data to Amazon QuickSight, which is like a way of, having dashboard based on data. I'm not an expert on QuickSight, but I think it's kind of the way I will go to basically having this kind of analytics dashboard. Then I think this is like one of the last requirements is like having being able to export the data. So here we go on to export a CSV file. So the idea is to have a Lambda function that query the DynamoDB table where we have the data or the events, and the Lambda function is going to create the CSV file, upload it to an S3 bucket, because we don't want to create an CSV file on the fly for every host that want to get the CSV file. So if the CSV file has already been created, we want to save it on the S3 bucket. And also, if the host has configured a third-party platform, like it can be HubSpot or Salesforce from the requirements, there's going to be an event from the S3 bucket that read the config, like an API key to push the data to Salesforce, and then it's gonna push the CSV file to the third-party CRMs. That was the idea. Hopefully, it's a good idea and it should work. And then here is like customization. Like I think like having been able for customer to upload a logo. We can do it with S3. And roles, again, I think it's going to be with Cognito and user pool. All right, so this was like my idea on how to implement the system. I reckon it can be high level or in some parts, but hopefully it's good enough, to get started. Now, as part of the challenge, basically, I think it's like after the first week, Sam sends like a self-review question list going through the well-architected framework and also challenge related questions. So I'll go through them and see how we reply. So let's start with the AWS Well ARchitected questions. So security, how do you secure your data in transit? So this like HTTPS, data at rest is DynamoDB is encrypted at rest, so shouldn't be any problem. How's your architecture protected against malicious intent? So for the API, I'm using Cognito, so only authenticated user can call the endpoints. For API again, if we want like DDoS protection, we might need to add the firewall from AWS. So we need to check that on the requirements. And for the database, so for the storage and S3, DynamoDB and S3 is only accessible from the API and Lambda function, and each Lambda function has a role based on what they need to do. So reliability, how would your infrastructure react if an availability zone went offline for 1 hour? Would your application still be usable? And blah, blah, blah. So since I'm using like services that are like deployed in multi-availability zone, I think there shouldn't be any failures. Maybe, I don't know. Honestly, it never happened of having like, an availability zone going offline, but I would expect maybe just some temporary failure, but it shouldn't happen because, as I said, services are multi availability zone deployed, so shouldn't be a problem. Whereas the question, the next question is about the whole region. I think the only thing that will work will be the React application because it's cached with CloudFront, but API will fail because they're not replicated in different region. But there won't be any loss of data basically, except for people not able to create events or joining events, this kind of thing. I think it's acceptable because a region going offline is a big event for AWS, so I don't think it's likely to happen really. How would your application react if your traffic increase 10 per in 5 minutes? Blah blah blah. Okay, so let's say we have 5,000 concurrent users and we grow to 50,000 users. So I checked the quotas for the WebSocket. The only limit is like 500 new connection per second. So we need to check if we are hitting this limit. I don't think we can. It's like we can change it. So there will be a limit that we can hit. Probably not. Maybe I don't know. Depending. It's per second. There's not a limit on how many users can connect to the WebSocket. It's just like a per second limit. So 500 new connection per second, I think, is a sensible limit. And for the HLS streaming, it's not a problem at all. If a developer added a recursive bug to the code, okay, in this case, since I'm using Lambda function, probably that single Lambda function with a bug will be unusable. But again, the bug is isolated to that specific function, so it shouldn't break anything else. And so we should just, it's going to be isolated to that specific function, basically. What will happen if your database was corrupted or accidentally deleted? I have point-in-time recovery for that DynamoDB table, so we can just recover based on where it was corrupted or deleted. And we can also add delete protection. Performance. So anything in your application cause user request to fail to meet latency requirements. This shouldn't happen because I'm using, API gateway and Lambda, so the performance is pretty good. Should be less than 1 second for each request. And again, if this is happening, we can add alarms and also having a look at the data based on the usage. How do you configure and optimize your compute resources? In this case, again, I'm using Lambda function, so it should be fairly optimized, but also I will say that based on the usage of users, I will probably have a look of the kind of average latency for the functions and check which one is low. So yeah, this is also actually the answer. What should the team be monitoring? So yeah, API response time, latency, errors, these kind of things. Cost optimization. Okay, so here I think the big amount of money we're spending is for the live streaming. I haven't calculated per Lambda function, but if I want to focus on the live streaming, so the Chime SDK with live streaming is basically on an event with 500 participants plus one host and one co-host is like 502 attendees multiplied by 60 minutes. This should be a multiplied symbol. Anyway, multiplied by 60 minutes, multiplied by the price per minute is $51 per session. And for the breakout room, I did like a quick calculation on the WebSockets, and it's literally just $2 per event with 500 users connected on the WebSocket. So the most expensive component is the media streamer. I don't think I can kind of optimize media streamer cost because that's the price to pay if you want to stream to N participants. And the design patterns to optimize cost is serverless. Right, so now let's move to the project-specific questions and things to watch out for. Okay, the first question is on the GDPR compliance. So I know that AWS services have GDPR, So, I mean, obviously, it's our concern, like our responsibility as the product builder to be sure to collect the data following GDPR principles. So, unfortunately, I'm not an expert, or I'm not like I don't have loads of experience on handling these kind of things. But here I apply, like putting like the advice for the cookies, accept all, or blah blah blah. So I probably need to dig more into this. But yeah, that's my answer. What's the latency of the video solution? So I chose, as I said, Chime SDK with RTMP. Low latency should be around 5-8 seconds at worst. At worst. If a user disconnects from any of the chat, yeah. So the idea is to store messages on DynamoDB, so we have an history, and also we can have like this data to check analytics on who's the most active user and these kind of things. Limitation on number of participants in the event. So on the video streaming, using this solution, there are no problem on scaling because basically we are like using RTMP with packets and HLS player. It shouldn't be a problem. How real time will your analytics be? Here I said fairly near real time, because I'm expecting like this data on DynamoDB. So I just need to understand what's the pipeline to bring this data live on a quick site dashboard. But I would expect this not taking like days. So maybe just a couple of hours probably. I have no idea. How are you tracking the number of participants who joined an event? This is used for billing. Okay, so the idea here, since I'm using WebSocket, connection, disconnection, I want to track these connection events. So I'm tracking each connection, disconnection event per user. So I am sure that I know who has been connected. And also I'm going to handle any failure on putting an item in DynamoDB, so I can kind of be sure who joined the event and also for how long. So you have a busy weekend and hit 5,000 concurrent participants. Estimate that they are each sending 2 messages per minute. Okay, I checked the quotas. Shouldn't be a problem really, because we're using. I haven't found any limits on how many messages you can send on the WebSocket. As I said, the limit is only on the connection, on the number of connection per second. So again, it shouldn't be a problem. So next question is, you're asked to add a feature, video chat for breakout teams. Okay, since we need video chat and it's going to be audio video two-way and everyone is seeing each other, we need like a two-way audio video communication. So we need to integrate Chime SDK with the video room capability. So probably needs a bit of work because we basically need to create a sort of Google Meet using Chime SDK. So I would say a couple of weeks of work for sure. A large company wants to do a company-wide hackathon. They have 15,000 staff. They want users to be able to log into the event using the company credential. You still need to support other customers whilst this event is happening. How complicated would it be to be extended your current architecture? So ideally, and still I need to investigate this a little bit further, but probably I can create a separated user pool for this company using the a SAML integration for single sign-on based on their credential, and this shouldn't affect the other users since I'm using a separated user pool for authentication. Hopefully. Last question, are there any known limitation? There are no limitations since video streaming can scale infinitely basically. WebSockets, we have the 500 connection limit, but other than that, really, yeah, it shouldn't be a problem. So that's all from me. I think it's a very, very nice and challenging exercise. If you want to try as well, again, I'm going to leave all the details for the challenge that, again, I want to say this was created by Sam Williams at Serverless Challenge. Um, let's Let me know if you have any comments, any feedback on my design. Really happy to discuss it with you. And if you like this kind of videos, make sure to like the video or subscribe to the YouTube channel if you like it. I try to push a video every week. So thanks again for watching and see you on the next challenge.